Good afternoon to one and all. I am R16, Assistant Professor, Department of Mechanical Engineering. Today in this video lecture, I am going to explain the gear tooth thickness measurement, that is the tooth thickness measurement by using two methods. The first one is the prominent one, which is a very highly used method, that is the gear tooth vernier. The second one is the constant chord method. And this is my 41st lecture regarding to the subject metrology. So we are going to explain the tooth thickness measurement here. So generally this tooth thickness is measured with the help of the pitch circle. So you have to measure it with the pitch circle only. And also in most cases the chordal thickness measurement is carried out. So you have to carry the measurement through the chord only, that is chordal thickness measurement, which is to be carried out. That is, the chord is joining the intersection of the tooth profile with the pitch circle. So this is to be joined. So the chord is to be joined with the intersection of the tooth profile with the pitch circle. So you all know about the difference between the chord and the diameter. So chord is the smallest distance than the diameter, and diameter is the longest distance which is passing through the center of the circuit. But chord is the largest distance, does not passes through the center of the circuit. So that is the main difference here. So the chord is joining the intersection of the tooth profile with the pitch circle. So you are going to see it with the pitch circle only. And the methods which are used for this gear tooth thickness, that is the measurement of gear tooth thickness, is four types. First one is the gear tooth vernier calipers method. So that is the first one, gear tooth vernier caliper method. It is also known as gear tooth vernier also. And second one is the base tangent method. Third one is the constant chord method, and last one is the measurement over pins or balls. So that is using the different pins or balls, we are going to take the measurement. So these are the four different types of methods we are going to carry on our work. So today I am going to explain the gear tooth vernier method. So based on the time, I am also going to explain the base timing method also and constant chord method also. So firstly we are going to see the gate tooth vernier method. So the most important method is the gate tooth vernier method. So let's see the first one, that is gate tooth vernier. So the tooth thickness can be very conveniently measured by a gate tooth vernier. So you have already known the measurement which is included in the vernier calipers. So it has a main scale as well as a vernier scale. Since the gate thickness varies from the tip of the base circle. So it varies from the tip of the base circle of the tooth, and this instrument must be capable of measuring the tooth thickness at a specified position on the tooth. So this is to be specified at the position of the tooth. Further, this is possible only when there is some arrangement to fix that position where the measurement is to be taken. So whenever you are going to take the measurement or take the reading, we are going to take some arrangement on this to fix the position in where the measurement is to be taken. Further, the arrangement is then removed after the measurement. The tooth thickness is generally measured at the pitch circle and is therefore referred to as the pitch line thickness of the tooth. So generally these are going to be measured with consent as a pitch circle. So taking the base as the pitch circle. So the gate tooth vernier has two vernier scales and they are set for the width of the tooth and depth from the top at which W occurs, that is the width occurs. So in the gate tooth vernier scales, they have to be measured with the set for the width of the tooth and depth from the top. So this is the measurement of tooth thickness by using the gate tooth vernier. So this is the gate tooth vernier in which it got the width section and the length section. That is the thickness. So generally it got a main scale and a vernier scale attached to it. So this is the main scale and this is the vernier scale which is attached to it, and the tooth thickness is generally measured at pitch circle and is therefore the pitch line thickness of the tooth. So this is considered to be as the pitch line thickness, in which we are using the pitch circle as the base. And the following method is used for the measuring of gear tooth thickness. So generally this following method is to be used. So it is conveniently measured by a gear tooth vernier, in which you can show in the figure also. So that is the gear tooth vernier. It consists of two scales, one on the vertical side and other on the horizontal side. And since the gear thickness varies from the tip to base circle of the tooth, the instrument must be capable of measuring the tooth thickness at a specified position. So this is used to be measured at the specified position. So when you are going to measure these tooth to a specified position on the tooth, and the gear tooth vernier has two vernier scales. So it has two vernier scales, that is the one for the depth, which is set to measure the depth scale, and one for the width scale, that is on which is used to measure the top surface of the width, while the horizontal scale is used to measure the widthness of the teeth. So this is the horizontal scale which is used to measure the width, and this scale is used to, that is the vertical scale is used to measure the height of the tooth. So then we are going to take the first one, that is the first method. So proper adjustment has to be done with the scale, that is this is the one adjustment to fix the scale to the specified height. Then this horizontal positioned scale is to be adjusted with reference to the scale. So this has to be measured with that fashion only. So proper adjustments has to be made to the measurement, in which it consists of two different types of scales. So here we are taking only one gear tooth. So considering one gear tooth, so the measurement values, that is the theatrical reading values of width and depth, can be found out, which may be verified by the instrument only. So in the figure you can check that. So it may be noted that W is a chord, that is the ADB. So here you can see the ADB position. This is the chord of the thickness of the tooth. But the tooth thickness is specified an arc distance between the AEB. So this is the A position, this is the B position, and this is the E position. With respect to the position, we are going to specify an arc distance, that is the and also the distance D can be adjusted on the instrument is slightly greater than the addendum CE. That is the CE is the addendum. So this is the CE position, which is to be. So that is to the caudal position, in which W is equal to AB. That is the two times the positions of the AD. So in the from the figure, W is called as width, that is equal to AB, that is of 2 into AD. So this is the AD position, so which is half of the position to the AB. And now AOD is equal to theta, that is equal to 360 by 4 n, that is 360 divided by 4. That is how quarter by part, where is n is the number of teeth. and W is equal to 2 into AD, that is 2 into AO sin theta, which is half of the value of the 2 into AO, that is sin theta. So by taking that, we substitute the values. R is radius, 2 into R into sine, 360 by 4 into N. So R is the pitch curve circle radius. So by considering this module, we are going to take module M is equal to pitch circle diameter. Pitch circle diameter divided by the number of teeth. So it is taken as the pitch circle diameter of number of teeth. Then pitch circle diameter is taken as 2R, that is the 2 into radius divided by N. So N is the number of teeth. Therefore, capital R is equal to capital N into small m by 2. So we are taking it as capital N into small m by 2. Therefore, W is equal to 2 into Nm by 2 by substituting the values. So 2 into R. So R value is N into M by 2 into sine 360 divided by 4N. In total, we got it as N into M into sine 90 by N. So this is the first equation. Then also the figure we got it as OC minus OD, that is CD is taken as OC minus OD. So OC minus OD means we got it as CD. Therefore, OC is equal to OE plus addendum. So we are taking it as addendum position also, OE plus addendum, that is R plus M. So we are taking it as R plus M value, that is capital N into M by 2 plus M. That is capital N into M by 2 plus M. And OD is also taken as O is the center and D is the half of the pitch circle radius. So OD is taken as R into cos theta. So R is the radius and theta is the angular distance in which it is measured with cos theta. That is N into M by 2 into cos 90 by N. Therefore, small d is equal to N into M by 2 plus M. So the small m is the factor there, that is for the radius N into M by 2. So by substituting these values, we got N into M by 2 into 1 plus 2 by N minus cos into 90 by n. So this is the second equation. So we are taking it as second equation. So this is the final curve, and any error in the outside diameter of the gate must be allowed for when measuring the tooth thickness. So when we are going to measure the tooth thickness for the outside diameter, so outside diameter of the gate, it must be allowed for the measuring tooth thickness. And in the case of helical gates, that is in the case of helical gates, the above expressions, that is 1 and 2, for the value w, that is width, it is obtained in the first equation, and for the depth, that is we got it as second equation. So for the width and depth, we got both the values from one tooth micrometer, that is gear tooth vernier. So in the case of helical gates, the above expressions has to be modified to take into account the change in curvature. So generally when you are taking the two values in one section, you have to change the expressions to be modified, which is in the change in curvature along the pitch line. And the virtual number of teeth, that is NV, for helical gates is taken as, so the virtual number of teeth NV is for helical gates is n by cos cube alpha, that is alpha is taken as the helix angle, so which is to be taken as the helix angle. And from the equations 1 and 2, that is hence in equations 1 and 2, n can be replaced by this helix angle, so that is it can be replaced by this helix angle n by cos cube alpha, and m can be replaced by mn, that is the normal module which is taken into account. Then by from the two equations we got w as the first equation and d as the second equation by substituting the helix angle. So we got these two equations, that is n into mn by cos cube alpha, that is mn is the normal module and cos cube alpha is the helix angle, that is alpha is the helix angle, into sin 90 by n cos cube alpha, that equal to n into m, capital N into m sin 90 by n. So this is the value for the width, and for the diameter, that is d, depth, it is taken as n into mn by cos cube alpha, so it is taken as cos cube alpha, that is 1 plus 2 cos cube alpha by n minus cos into n minus 90 by n minus cos cube alpha. So these formulae apply when backlash is ignored. So this has to be applied, and this formula has to be applied when there is no backlash. So backlash is ignored in this. On the mating gates having equal tooth thickness and without addendum modifications, the circle tooth thickness equals half the circular pitch minus half the backlash. So by taking the circular pitch and the backlash as the two modules, we are going to measure the circular tooth thickness. Next, we are going to see the disadvantages of the gear tooth vernier method. So, this gear tooth vernier is not closer to 0.05 mm. So, generally, the least count of the gear tooth vernier or vernier calipers is 0.02 mm, which is the least count, and two vernier gearings readings are required. So, when you are going to measure these gear, gear tooth, you are going to take two vernier readings which are to be required. Next, measurement is done by edge of measuring jaw and not by the face. So this measurement is used to done by the edge of measuring jaw, not by the face of it. So we use it to touch the tip of the measuring jaw. Next one, general applications of the gear tooth vernier calipers. So generally, these gear tooth vernier calipers is used to measure the thickness of gear teeth at the pitch line or caudal thickness of the teeth and the distance from the top of the cord to the tooth. So this is used to be measured from the tooth to the cord, and the thickness of your tooth at the pitch line and the addendum is measured by an adjustable tongue. So this is used to measure by an adjustable tongue. So the effect of zero error should be taken into consideration. Here we are going to take the adjusting screw with the adjustable tongue, which is used to measure the addendum and the thickness of the tooth. So this is used by adjusting screw on the graduated bars, and this effect of zero error should be taken into consideration. So the effect of zero error should be taken into consideration, and this method is simple and inexpensive. So this method is going to be very simple to measure and inexpensive. That is, without any other expensive device, we are going to measure it. And however, it needs different setting for a variation in number of teeth for a given pitch, and accuracy is limited by the least count of the instrument. So the accuracy is to be limited by the least count of instrument, since the vary during is concentrated by two jaws. So we are using the two jaws here. So this is the first jaw and this is the second jaw. So each individual scale has one jaw to it, and we are going to measure it with the jaws only. since the wear during the use is concentrated on the two jaws. So we are going to measure the two jaws with the help of the two jaws. The caliper has to be calibrated at regular intervals to maintain the accuracy of the measurement. So to maintain this accuracy, we are going to calibrate the regular intervals to maintain the accuracy of measurement. So these are to be the general advantages. So regarding to the gear tooth vernier calipers. So whenever we are going to measure these gear tooth vernier calipers, we have to be good maintenance system because two readings at the same time can be taken. That is the depth and the width, which is engraved on two scales. That is, these are the two scales which is to be engraved on that. So these tools have to be take measurement from these two jaws. So these are the two jaws, and this is the teeth. So you can see the teeth here. So this is the teeth in which these jaws tip is going to touch, but not the flat faced end. So this is the flat faced end. So these are not going to be touched, but only the tip of the jaws are going to be touched. So that is why some good calibration has to be taken while measuring these jaws, and some proper adjustments also are need to be taken. So this is the adjustment nuts for the horizontal section and two more adjustment section for the vertical section also. So this is the first method of measurement of tooth thickness. So in the later section we are going to the second method. Thank you.